Lesson 3, we're getting into equations. How do we solve equations using addition and subtraction? So first of all, two equations are equivalent equations if they have the same solutions. So equivalent equations means they have the same solutions. So first we have some properties of equality I want to talk about. So the addition and subtraction properties of equality can be used to write equivalent expressions. So when we have the addition property of equality, what that is telling us is that adding the same number to each side of an equation produces an equivalent equation. So essentially, if you add to one side, you have to add to the other in order for it to remain the same. I always like to think of a scale. And I'm not talking about like a scale you step on to weigh yourself. I'm talking about one where you might weigh like fruit or other items and it has two sides to it. If I add maybe 3 apples to one side, in order for it to remain equal and level, I would have to add 3 apples to the other side to kind of even it out. So whatever you do to one side of something, you have to do to the other in order for it to remain true and equal. So same goes for the subtraction property of equality. Subtracting the same number from each side produces an equivalent equation. So if I take $3 from you, right? Say you and your friend Mark have $6. For it to be fair and equal, if I take $3 from you, I should take $3 from him, so you guys still have the same amount. So whatever you do to one side or to one thing, you have to do to the other in order for it to remain equal. So remember that, and we'll practice that. So we're going to just solve some equations just to walk through the steps. I'm going to show you kind of how we like to see it set up. We do need to see your work. What are you doing to both sides? And then also, how do we check our answers? So when we're solving equations, you're going to be checking your answer a lot, because there's a way to know whether you're right or wrong, right? You could do all these problems and know for sure whether you're right or wrong by doing a check. So let's look at number 1 here. X minus 5 equals -1. So first of all, real quick, I have this box to the right up here that I want to kind of review before we kind of get into this problem. When solving equations, we undo what is happening to the variable. We can undo an operation by doing its inverse. Very important. What are inverse operations? I want you to think maybe what the word inverse means. Another word for it. We can undo an operation by doing its inverse. Inverse means opposite. So what are opposite operations? So if I see addition happening, what would be the opposite of adding something? Hopefully you're thinking subtracting. So adding and subtracting are inverses. So if I add, the opposite would be to subtract. Go ahead and write that down. I'm going to abbreviate because I don't have enough room. What's another pair of inverse operations? Adding, the opposite is subtracting. I can even flip that. If I'm subtracting, my opposite would be adding. But I want different operations now. If we were multiplying, what would be the inverse of multiplying? Hopefully you're thinking dividing. So multiplying and dividing are inverses as well, and that's good to know. So let's write those. Oh goodness. Some technical difficulties here. Here we are. So go ahead, finish writing off the word dividing. And now let's refocus back on this number 1 over here to the left. So you're always looking at what's happening to our variable. Right now, x is being subtracted by 5. So we're going to solve this equation by undoing what is happening to the variable. Our variable here is x. So take a look at what's happening to x right now. X right now is being subtracted by 5. Let's do its inverse operation. What's the opposite of subtracting 5? We're going to add 5. So I'm going to add 5 to both sides because whatever I do to the left, so what I'm going to do is I really would like you to write this down exactly how I'm writing it. So you should have your notes in front of you. You're going to work with the equation that's given and we're going to work right below it. So right now where that subtracting 5 is, let's put plus 5 underneath because the opposite is to add 5. Now subtracting and adding 5, they're opposites. They're going to cancel each other out. And that's the goal here, is to get your x by itself. Now, whatever I do to one side of my equal sign, so I'm going to split this. See how on the left I added 5? I have to now do that on the right as well. So remember, whatever you do to one side, you have to do to the other side. So let's see what all of this equals. So you want to actually combine. These are like terms, they're constants. I can combine them. What does a -1 and a +5 give us? Maybe you're thinking of our rules, SADS. Same sign add, different signs we would subtract. Take a look at these. I have a -1 and a +5. Those are different signs, so I should be subtracting. What's 5 minus 1? 4. Take the sign of your larger, it would be positive. Wherever your equal sign was before, you keep it. Bring it right down. And now, what is left on our left side here? This canceled, so all I have left is my x. So that tells me x equals 4. That's our solution or our answer. So let's check if we're correct. So this is my answer. In order to check, you're replacing what you found x to be in your original equation. So if x is supposed to equal 4, let's replace 4 minus 5. We're going to see, does that equal -1? That's what you're checking. So let's actually do this now. 4 minus 5. I see subtracting of integers, so I'm going to keep, change. So now I have 4 plus a -5. Different signs I would subtract. Keep the sign of the larger. Did I get -1? Does -1 equal -1? I did. I did my check, so I know I'm correct. So x does in fact equal 4. Let's try this second one. A little bit trickier. If you notice, I have fractions. I know fractions are some of our favorite things. Take a look at y here. So I have y plus 3/2 equals 1/2. What is happening to our variable right now? You should always find your variable and look what's on that same side of the equal sign with it. Right now, y is being added by 3/2 or 3/2. How am I going to get rid of plus 3/2? I'm going to subtract 3/2 on each side because that would cancel this out. Remember, if you want to draw a nice line where your equal sign is, some of us like to kind of set up this upside down T, that is totally fine. So when I add 3 or subtract 3/2 on the left, I also have to do that on the right. Now take a look. I have a positive 1/2 and essentially a negative 3/2. Different signs, I should be subtracting them. They already have a common denominator, so I can just subtract my numerators. What's 3 minus 1? It should give you 2/2, which really equals 1. I can simplify it. Now, don't forget, we have to take the sign of our larger number. Remember, y was the only thing left over here. Bring down your equal sign so it equals 2 over 2 or 1. And now, is 3 over 2 or 1 over 2 greater? So my answer should be -1. Let's check ourselves. In order to check, you plug in what did you get for y? Replace that in your original equation. So I'm going to replace a -1 here and then do this math. I'm trying to decide, is -1 plus 3 over 2, does that equal 1/2? That's what you're basically finding out. In order to add these or subtract, we have to have them with the common denominator. So this is really over 1. I want to change it to 2. So I'd multiply by 2. So I'd multiply by 2 on the top. So -2 over 2 plus 3 over 2. They have different signs, so I would subtract them. Subtract just your numerators. So 3 minus 2 is 1. Keep your denominator. Take the sign of the larger, so be positive. Did I get 1/2? Yes, I did, so I know I'm correct. All right, let's walk through one more together, and then it'll be your turn to try some out on your own. So let's take a look at number 3. We're now dealing with decimals. So I'm looking for my variable, what's happening to z right now. It's being added by 13 and 2/10. So in order to get rid of that, or to undo it, I'm going to do the opposite. I'm going to subtract 13.2. Whatever I do to one side, I have to do to the other. Guys, as soon as you do that opposite, this should always cancel. It's not even a question. So exit out so you don't get yourself confused, and then bring down your variable. Maybe put your equal sign. And now the only thing left is to actually do that math on the right side. Notice that these have different signs, so I need to subtract them. But be careful, when we're subtracting decimals, we have to line up that decimal, but we also should have the bigger one on top. So this I need to flip to be on top. So whether you want to move it or you just want to go ahead and rewrite it, up to you. But you always want your larger decimal on the top. Line up your decimals. And now let's subtract them since they have different signs. I'm going to bring down my decimal so I don't forget. I have to borrow. 12 minus 4 is 8. 2 minus 0 is 2. So I got 2.8. And now let's decide, should it be positive or negative? Well, which is larger? This one, right? So it should be negative. Good. So now that's our solution. Do a check. How do we check it? We're plugging in -2.8 for z in your original equation. And I'm going to solve this now, the left side, to see if I'm going to end up with 10.4. So I'm looking, these have different signs, so I should subtract them. Remember, subtracting decimals, we're going to stack them on top of each other. I'm going to borrow. That gives me 4. That gives me 10.4. Take the sign of the larger, so it should be positive. Wasn't that what the original wanted me to get? So I have a nice check. I know that I'm correct. So if you solve it correctly and then you check it correctly, you can basically know whether or not you're right. Like when you're taking a quiz, you go through and check all of them and know, oh, I'm going to get a 100 here. Unless maybe you made a minor mistake. So that's where you really do have to take your time though. Remember your signs, but by doing that check should help you